Welcome to a video on the difference quotient. One of the basic definitions in calculus employs the ratio f of x plus h minus f of x all over h, provided that h is not equal to 0. This is what the difference quotient is defined as. In this example, we'll be going over evaluating the difference quotient using two examples, one using a linear function and two using a quadratic function. We'll start with the linear function f of x equals 3x minus 5. So to evaluate the difference quotient, we'll start with its definition. And to evaluate f of x plus h, we're going to replace the input value here, x, with the expression x plus h. So this simplifies to 3 times the quantity x plus h minus the number 5. This defines the first term of the difference in the numerator of the difference quotient. Follow this is the function f of x. So our function here is 3x minus 5. Now make sure we subtract in parentheses so that we know that our next step is to distribute that negative sign through. Without the parentheses, we would only subtract the first term of the function, which is incorrect. So be careful with this part. And then we divide all this by h. Next, we would evaluate using the order of operations. So within the brackets, we're going to distribute the 3 through, which gives us 3x plus 3h, and then minus 5. And now subtract the quantity 3x minus 5, which is now negative 3x plus 5. Divide all this by h. Notice that we can cancel out the 3x term since one of them is positive, the other is negative. Likewise, the negative 5 and the positive 5 add to 0. So we're left with simply 3h from the numerator, and then we have an h in the denominator. Here we can divide out the common factor, which is h, and so leaving us with just the value 3. And that is the difference quotient for the function f of x. Now we're going to move on to part B. Note that in part B, the function is defined as a quadratic function, 5 plus 4x minus 2x squared. Again, to evaluate the difference quotient, we'll begin with its definition. We'll start with evaluating f of x plus h. So once again, replace all the x here with the expression x plus h. That gives us 5 plus 4 times the quantity x plus h minus 2 times the quantity x plus h squared. So this entire expression here represents f of x plus h. We're going to put all that in parentheses. And now we're going to subtract the function f of x. So function f of x is this entire expression right here. And so subtract in parentheses once again. So 5 plus 4x minus 2x squared, all in parentheses. Divide all this by h. And now simplify. So within the brackets, we have multiplication, quantity x plus h times 4, and we have a squared here. So based on the order of operations, we're going to square the quantity x plus h out. So one way to do that is to FOIL. And then once we FOIL, we can distribute the negative 2 through, since exponent comes before multiplication. So our next step is to evaluate this expression. Here we have 5 plus 4x plus 4h minus, now if we FOIL the first term times the first, it's going to give us an x squared. times that by the negative 2. So that would be negative 2x squared. From FOIL, the outside and the inside will give us x times h and h times x. So those are considered like terms. So we have 2 times xh, and then we're going to distribute the negative 2 through, hence giving us negative 4xh. And then from FOIL again, the letter L represents last. So basically h times h, and then distribute the negative 2 through, hence negative 2h squared. Close the parentheses. So all this represents the expression f of x plus h. Now, on the side, I'm going to just make a note that the quantity x plus h squared is the same as x plus h times x plus h. And if we simplify this, using FOIL, we get x squared plus xh plus hx plus h squared. Again, notice that the outer and the inner terms are like terms, so we take their coefficients and combine them. So xh is the same as hx, which is now combining them to xh, and then plus our last term, which is h squared. So we're basically taking this expression and distributing that 2 through, and that's going to give us these 3 terms right here. Okay, so let's move on to our next term from the difference quotient. Here we are going to subtract quantity 5 plus 4x minus 2x squared. That's going to change the signs on all those terms. And then divide all this by h. Now at this point, I can remove the parentheses from the expression f of x plus h, since there's not much we can do within the parentheses. Combining like terms from the numerator of this expression, notice that the negative 5 and the 5 add to 0. We have a negative 4x and a positive 4x. They add to 0. And we have a positive 2x squared and a negative 2x squared. They add to 0. So what's left is 4h minus 4xh minus 2h squared all over h. Now to divide out h in the denominator of this expression, we need to express the numerator as a product. So one way to do that is to factor out the GCF, which is the greatest common factor from the numerator. They all have an h in common, so we're going to factor that out, leaving us with 4 minus 4x minus 2h all over h. From here, we can divide out the common factor, which is h, and so leaving us with an answer of 4 minus 4x minus 2h. And this is the difference quotient for the function f of x.